Hello all, welcome to this quick but super useful lecture on diagonal matrix, which is another special type of matrix that will have non-zero elements diagonally and rest all the elements will be zero. For example, identity matrix. So identity matrix can be considered as a diagonal matrix. However, it is important to understand that a diagonal matrix will have any non-zero values diagonally. And yes, rest of the values will be zero. And this also can be considered as a diagonal matrix. So although identity matrix is a type of diagonal matrix, but it is not the only type of diagonal matrix, because the idea is to have non-zero elements diagonally. Moving forward, a square diagonal matrix can be denoted as diagonal x, where x is the vector of all the diagonal elements. So for example, if we consider this matrix as matrix A, and since it is a square matrix with 3 rows and 3 columns, hence this can also be denoted as diag of A, where A is the vector of the diagonal element. So for this case we have 2, 4 and 6. Okay, moving forward, it is computationally really efficient to calculate the multiplication or inversion of a diagonal matrix. So first let's understand that how it becomes easier to calculate the multiplication in case of a diagonal matrix. So let's consider a matrix X of shape 3 by 3, and I will put random values like 2, 3, 6, 5, 8, -1, 9, 2 and 7. And if I try to multiply this matrix X with this another matrix A, which is a diagonal matrix, and of course the multiplication is possible because the number of columns here in matrix X is 3 and number of rows here in matrix A is also 3, hence we can understand the multiplication is possible. In that case, while multiplying the matrix X with this matrix A, the computer does not have to do the multiplication between two matrices. In fact, it can do the same thing by multiplying the matrix X with the vector A that we have here, and hence now it becomes easier to find the product between these two tensors. Okay, so we have understood that how the diagonal matrix is making it simpler to find the product. Now also let's understand that how it is making easier to find the inversion of a matrix. So I will simply erase these things because the screen is looking really messy. Okay, so let's say that we need to find the inverse of this matrix A. In that case, all you need to do is, for all the elements diagonally in this diagonal matrix, you will have to inverse it. So I will do 1 by 2, then 0, 0, then 0 and 1 by 4, another 0, and then 0, 0, 1 by 6. So you see, it has become very easier to calculate the inverse because all we are doing is we are taking the inverse of this vector diagonally within this matrix. Okay, so we have understood that how it is making easier for us to calculate the multiplication or inversion, and to be precise, it is not making it easier only for us but for the computers as well, and hence we are saying that it is computationally efficient or cheaper to calculate these two. And one last thing to understand, that a diagonal matrix can also be non-square as well, although it is very less likely to come across a non-square diagonal matrix in machine learning. But of course, a non-square diagonal matrix also exists. And that is it for today's lecture. In the next lecture, we will learn about orthogonal matrix, and hence I will request you to watch the lecture on orthogonal and orthonormal vectors that you will find within this mathematics for machine learning playlist, because that is sort of a prerequisite. Thank you very much for your time today, and I will see you in the next lecture.